For this video, we're going to be discussing the characteristics of functions. So we're going to be doing this by looking at graphs mostly. So we're going to talk about all the different characteristics of the graphs of a function. So the first thing we're going to talk about is the domain. So the domain refers to all of the possible x values of a function. Okay, so x being our horizontal axis. The domain is just all the possible x values. We're going to write it looking like this. It's going to be d colon, and then we're going to use what we call interval notation. And interval notation kind of looks like a ordered pair, but really what it just does is it shows us the set of all of the numbers that are in this interval, an interval just being a space. So for domain, our interval notation works like this. We start with the number that's on our left end, and then our next number is the number that's on the right end of the function. Now, interval notation works a little weird depending on whether a number is included or not included. So numbers that are not included would be represented by like a hole in the graph, like an open circle. Included numbers are numbers that are included with like a point or a line. For included numbers, we use brackets, and for not included numbers, we use parentheses. Now, this is going to make more sense as we go on and as we look at some examples here. We're also going to be talking about the range. Now, the range is similar to the domain, except now we're talking about all of the possible y values of a function, y being the vertical axis. In range, we also use interval notation, and instead of from going left to right, for range, we're going from lowest to highest, and we're going to be looking at y values. So let's talk about the domain and range of this function that I've got graphed here. So we can see that this line goes all the way up to the left, and it keeps going on. It should really have some arrows on the end of it. It should similarly also have some arrows on the right side of it. And these arrows represent that this function goes on forever and ever and ever and ever and ever onto the left, and forever and ever and ever onto the right. So we represent that by saying that this graph to the left is going to negative infinity, and on the right, since it goes on forever, it's going to positive infinity. So the domain is from negative infinity all the way to positive infinity, because it includes all possible x values. And because infinity is not really a number, we use the parentheses for not included, because this just goes on and on and on forever. It doesn't actually go to a number. Now for the range, it's a little different. Okay, for range, we can see that this graph goes up forever in both directions, but it doesn't go down forever. It actually has a lowest point. These 2 points at the bottom here are the lowest, and they're both at negative 20. So our range is going to be from negative 20, our lowest point, and because the arrows are pointing up, this goes up forever, this goes to infinity. So our range is from negative 20 to infinity. Notice I use the bracket because negative 20 is a number that is included, and then for the highest point, I used infinity, or I used a parenthesis because infinity is not a number, so we can't call it as included. So that's how we do domain and range. We're also going to talk about intercepts. So intercepts are our next part of a function we want to talk about. And intercepts are just where the graph crosses the two axes. So the x-intercepts are the points where the graph crosses the x-axis, and the y-intercept is the point where the function crosses the y-axis up here. All right, so every graph, or not every graph is going to have a y-intercept. Not every graph is going to have an x-intercept. Some will have more than one of each, and we'll talk about that as we go. All right, we also want to talk about intervals. So a function can be increasing, decreasing, or constant at different intervals. And to figure this out, we want to think about it this way. As we move from left to right, we want to know, is the function going up, is the function going down, or is the function staying the same? Is it flat? So as we move from left to right, okay, if we are going up, then that's increasing. If we're going down, that's decreasing. And if it's flat, it's constant. And we're going to use interval notation again here. Okay, for these intervals, we always just use the parentheses because at a point, a function isn't doing any of these things. It has to be doing it over a few points. So this is increasing from this point here to this point here. And for these, we only want to use x values. We don't want to use y values here at all. We're only going to use our x values. So if we're only using x values, the x value at this point is -6, and the x value at this point is -2, so this function is increasing from -6 to -2. Then at this point, it turns, and now it starts decreasing. So it's decreasing from -2 to this point, and this point is at +2. So this is decreasing from -2 to +2. And then it is constant from that point to, and this graph goes on forever. Should put some arrows here. This graph goes on forever. So it's constant from 2 to infinity, because now it's just flat for the rest of the graph. So that's how we figure out our increasing, decreasing, and constant intervals. Our final set of characteristics we need to talk about is end behavior. And end behavior is just what's happening to the graph at either end of the graph. So you're always going to see end behavior represented like this, as x goes to some number, f of x, so the function, what number is that going towards? So think of this as x and this is y. Right, and you'll notice I've got two sets here. And the way you want to think of this is one of them is what's happening on the right, and one of them is what's happening on the left. So let's take a look at our graph. Let's start with the right. As I move to the right, my graph has these arrows at the end of it. Okay, meaning that this graph goes on and on and on and on forever. It just keeps going. It never stops. So on the right-hand side, x is going to infinity. It's just going on and on and on forever. So if x is going to infinity, and then we want to look, okay, it's moving to the right forever and ever and ever. What is happening to the y value? Is it going up or down? Well, it's going up, and with these arrows, it's going up forever, so my f of x is also going to infinity. Now I want to do the same thing on the left-hand side. So on the left-hand side, my graph has an arrow on it, so it is going to negative infinity, because over to the left-hand side, if we think of the x values, it's like -5, -6, -7, -8, -9, and so on and so on and so on, down to negative infinity. But my graph is going up as well. So because it's going up, this is wrong, this should be also positive infinity. Okay, because this graph is going up and up and up forever. So as x goes to negative infinity, the graph also goes to positive infinity. So that's how end behavior works. So let's look at some examples. So let's describe the characteristics of this function. And this function should really have arrows at the end of it, signifying that it goes on forever. So let's talk about all our different characteristics. First off, domain. Well, because I have an arrow going to the left and I have an arrow going to the right, my domain is from negative infinity to positive infinity. Anytime you have arrows facing one to the left and another arrow facing to the right, then your domain is going to be this, negative infinity to positive infinity. For the range, I have one arrow pointing down, meaning that this graph just keeps going down forever and ever and ever, and one arrow pointing up, meaning that the graph goes up forever and ever and ever this way. So my range is also going to be negative infinity to positive infinity. Now I want to talk about where this graph is increasing. And this graph is increasing in two places. You can see it's increasing here at the beginning, then it stops here. So it's increasing from negative infinity up to -1. Then it turns and it goes down, and then it turns again, and now it's increasing from 1, and it's going to increase forever from there, so it's increasing from 1 to infinity. Now where is this graph decreasing? Well, it's decreasing from this point down to this point. So that's from -1 to +1. Where is this graph constant? Well, at no point is this graph ever flat, so this is just never constant. We just put none, or NA. This is just not ever a constant function. For our intercepts, well, we have 3 of them. We have one right here, we have one right here, and we have one right here. These are x-intercepts. This one is also an x-intercept, this one's also a y-intercept. So we just want to write the coordinates. These two, it's kind of hard to tell, but we're going to say that that's negative 1.8. This one is 0, so this is negative 1.80, that's the coordinates of that point. This one is at 0, 0, and this one is at positive 1.80. And those are our intercepts. Now our end behavior. Let's look at our end behavior. Let's start on the right-hand side. So as I go to the right, I'm going to keep going to the right forever. So x is going to infinity. And as I'm going to the right, I'm also going up forever. So f of x is also going to infinity. On the left-hand side, well, I've got an arrow, so my x is going to negative infinity. It's going on forever. And my graph is going down, so f of x is also going to be going to negative infinity. All right, let's take a look at one more example. This function's a little different. Instead of having arrows, this one has endpoints. So our answers are going to be a little bit different. So for this one, because I have an endpoint here at 2 for my domain, or an endpoint here at 0 for my x value, this is the point 0, 2, and this is the point 7, 0. My domain starts at 0, and it moves to this point, which is at 7. So my domain is just 0, 7. Notice there's no infinities here because my graph doesn't go on forever. It stops. Also notice that I use brackets because both of these points are included. For range, I want to go from lowest point to highest point. So here's my lowest point, where the y value is 0. And then my highest point is up here, where the y value is 6. So my range is from 0 to 6. Now let's talk about where this is increasing. Well, it's increasing here from x is 0 up to x is 3. So it's increasing, that shouldn't say 2. That should say, well, it doesn't want to let me do it. This shouldn't say 2, that should say 0. So it's increasing from 0 to 3. And then it's decreasing here, and then it kind of changes, but it's still decreasing. So it's decreasing from 3 to 7. Now once again, this graph is never flat, so it's never constant. And then it has 2 intercepts, the y-intercept at 0, 2, and the x-intercept at 7, 0. Now, our end behavior. End behavior is a little weird on this one. Let's do the right-hand side first. X is not going to be going to infinity here. X stops. So on the right-hand side, X goes to 7. And we want to know, what does the graph go to as X goes to 7? Well, the graph goes to 0. Notice this is the end point of the domain. X is the end point of the domain. Now, on the other end, as we go to the left, X is going to 0, and f of x is going to 2. Right? Because those are our endpoints, and we don't have our arrows telling us that these go to infinity. Right? So hopefully, after watching this video, you were able to come up with some characteristics of functions on your own, and you're able to identify all of these characteristics on any function graph that you are given.